Right. Okay. Greetings and welcome to the lecture on engineering mechanics. So we have discussed this problem number 2 and problem number 3 based on equilibrium. So we have solved the problem number 2 and this problem number 3 by applying the conditions of equilibrium, that is summation fx0, summation fy0 and summation moment is equal to 0. Okay. So most of the time okay, here in general, the procedure is the first step is to draw the free body diagram of a given body. And once you draw the free body diagram, then you apply the conditions of equilibrium and then solve for the unknowns. So most of the time, we have to apply summation moment is equal to 0 condition. Okay, so you take moment about such a point where there are maximum number of unknowns. And then you apply the next two remaining conditions, that is summation fx0 and summation fy is equal to 0 to solve for the unknowns. Okay, so already we have discussed this process, right? So just I will give you the hint how to solve this problem number 4. Already I have shared these PPTs with you all. The same process we are going to apply what we did yesterday. I mean the moment 0, so fx0 and fy is equal to 0. Yes, to just go through the problem. So here drawing the free body diagram of this particular problem is very important. Now how I am going to construct the FBD is a very important, right? So just go through the problem. To remove a nail, a small block of wood is placed under a crowbar and a horizontal force P is applied as shown in the figure. Okay. So this is the crowbar, okay, A, B, C, and it is required to remove this nail. So this is a nail. Nail is a vertical. Please note that, right? So knowing that this small L is equal to 88 millimeter. So what is the small L? L is the horizontal distance between this point B, where the crowbar, the end B of the crowbar rests on this wooden block. Okay. So the distance, horizontal distance between point B and C is the nail point, is 88 millimeter and the force P is 130 Newton. Determine vertical force exerted on the nail and the reaction at B. Now see, this is a practical problem. You might have observed this kind of crowbar which is used to remove this nail. Okay, so here we apply a minimum force, just 130 Newton force, and here the force required, the force induced in the nail may be of, say, what we can say, the large magnitude. Okay, now see here how I am, of course, now the first step is to draw the free body diagram of this crowbar, right? So this is something like this, a crowbar as shown in this figure, something like this, right? Okay, right. Now here please note that I am going to draw the free body diagram only of this crowbar A, B, C, right? A, B, C, right? So what are the various forces acting on it? Of course, this external force applied at end P, at end A, whose magnitude is 130 Newton, which is given in the problem. Okay. Then of course, what about can anybody answer? What about what is the nature of force induced in this nail? Yes. Is it a tension or compression? It is given in the problem. If you go through the problem, then you will come to know. It is clearly mentioned in the problem.
Tension.
Yes, very good. The tension. Okay. So there is a tension in, because when you apply a force P onto this crowbar in rightward direction, then what will happen? The end C will get lifted up, right? Okay, and hence the tension T is developed. And as we are drawing FBD of ABC, I mean the crowbar ABC, and here the point under consideration is the point C. Okay, or say this whole crowbar ABC. So how the how the tension is represented? Tension is represented by away from point C. Okay, so let this T is the tension induced in this nail. Okay. Yeah, now I have shown these two forces, the applied force T, then tension T. Here we know P is in horizontal direction while T is in vertical direction. Okay, it is mentioned in the problem. To remove the nail, a block of this, okay, used, knowing that L is equal to this much, Determine vertical force exerted on the nail. So nail is exactly vertical. Okay, it is vertically inserted in this wooden block and it is required to remove it. So no doubt the line of action of this tensile force is a vertical one. Please note that, right? And as far as the FBD of this thing, the crowbar is concerned, the tension T is acting in vertically downward direction, right? Yeah. Any other reaction or any other force acting on this crowbar? Can anybody answer quickly?
Normal reaction at B.
Normal reaction at B. That's all. Any other
And
reaction? Fine.
also
Okay.
force acting on B, leftward or rightward.
What is that force? Okay, that's good. Very good. Fine. Fine. Very good. Very good. See now, if you recall this one statement which I discussed. So in general, see here. Yeah, this one, equilibrium of three coplanar non-parallel forces. So suppose this is a body which is acted upon by three coplanar non-parallel forces, and if that body is in equilibrium, yeah, that's what this is the conclusion. If a body is acted upon by three coplanar non-parallel forces, and if that body is in equilibrium, then these three forces must be concurrent. This is very important conclusion. Okay, so using this particular, what I can say, the conclusion, yeah, here, right? So here I know line of action of tension T, I know line of action of P, and of course they must meet at this particular point. Okay, right? So no doubt through which point. Okay, so suppose this is the reaction is to be developed at this particular point B. So no doubt the reaction at B must be directed, say suppose this point of concurrent, I mean the point of meeting of P and tension T is somewhere here, say suppose O. Okay, so P and T, they are meeting at point O. So what should be the line of action of the resultant reaction which is to be developed at point B? No doubt it must pass through BO. Okay, I mean it's the line of action of RB must be along BO. It must pass, RB must pass through the point where the P and tension T is meeting. I mean they are passing to, they are meeting, right? Okay, I hope you have understood this point, right? So now what you do, you find the angle by applying the geometry. You know this the length of the crowbar AB is 900 millimeter. Then this is L 80 millimeter. While this angle is known, then construct this is something like this right angle triangle. Say A B C. Say suppose this is D point. Okay. Then by using geometry, you can find out the angle made by RB with respect to either vertical or horizontal. Okay, this is how now you can construct the FBD. The other way is what now? Instead of showing this RB as a single force, what I will do, I will resolve this RB into two components, which I have shown here. Okay, see here. Now what I have done here, I have, instead of showing only one force as a, I mean resultant reaction at B, I have shown two. I have resolved that RB. I have resolved this RB into two rectangular components, one along x-axis and second along y-axis, which is Bx and By. Okay, and then you apply the conditions of equilibrium. Now see here, as far as I resolve this RB into two components, how many forces are acting on this crowbar? 1, 2, 3, and 4. Okay, so then now this problem of three coplanar concurrent force system, I have replaced, or I have converted into a problem into coplanar concurrent, coplanar non-concurrent force system, coplanar non-concurrent force system, right? And hence and now here in this example, now as far as this FBD is concerned, there are four forces. So we have to apply the three conditions of equilibrium, that is moment 0, then Fx0 and Fy0. Okay, so of course I have to take moment about point B first, because maximum number of unknowns are passing through point B. So if I take moment about point B, then there will be moment of P and moment of T, right? And in that equation there will be only unknown T. Yeah, the calculation has been done for you. Okay, and already I have shared this PPTs with you all. Just you go through this solution, right? The other way is what you can find this angle made by RB with respect to horizontal, and then what you do, you may use that sine rule. Okay, so now this will be something like this. So this is your figure, right? So this is the point of concurrent. So this is your RB, while this is your P, okay, and this is your tension T. Okay. Only the thing is that by using geometry, you have to find out this angle made by RB with respect to horizontal. This is what, right? Fine. Let's try at home. Okay, fine. Now let us discuss next topic, that is beam. Okay, the types of beams, right? So already while conducting the experiment, second experiment, I have defined what is meant by beam, right? So here I have given the definition. So beam is a horizontal structural member which is subjected to loading in transverse direction, because of which it tends to bend, right? So already we know what is meant by beam. Say this is a horizontal structural member. Okay, say for example it is something like this, which is, say, suppose resting on, say, these two columns, right? Now this is the major axis of say this is fine, x-axis is the major axis of this beam. This is also called as longitudinal axis, right? And axis which is normal to this major axis x is called as the transverse direction. Okay, so the transverse direction is perpendicular to the major axis, right? So this beam is subjected to loading in transverse direction, something like this, say P, and so suppose P1, P2, etc., right? And because of the application of this loading in transverse direction, what happens? This beam tends to bend as shown in the figure, something like this, right? So this is might be fine, but I can say the deflected shape of the beam due to the application of loading in transverse direction. Okay, so this is what the simple definition of the beam, right? Now what are the different types of beams? So depending on the type of support, the beam can be classified as. Now we have seen the different types of support, such as hinge support, right? Then roller support, and then fixed support. Okay, usually these types of three supports are used in case of beams, either hinge support or roller support or fixed support, right? Fine. So depending upon the type of the support, the beam is classified as simply supported beam, overhanging beam, cantilever beam, continuous beam, beam fixed at one end and simply supported at other end, then fixed beam, and then compound beam, right? So in our syllabus, we are going to deal with only this blue colored beams. That means simply supported beam, overhanging beam, cantilever beam, and compound beam. Okay, here for the analysis of all these four types of blue colored beams, we are going to apply those same, in general, those three equations: fx0, fy0, and moment 0. Okay. So these three conditions of equilibrium we are going to employ to solve for the unknowns. Same steps we are going to employ what we have employed for the previous problem 1, 2, 3, and 4. Right? Now see, these are what the sketches for the different types of beams. This is the sketch for simply supported beam. Now see, in case of simply supported beam, usually one end is a hinged one and the other end is a roller one. Okay, so why it is done so? One end is a hinge and other end is a roller one. Say we know what is meant by hinge support. So hinge support allows rotation, correct? So rotation is allowed, correct? RO, I am considering say RO as rotation. But what about translation? Translation is not allowed, correct? And what about the roller support? Roller support allows rotation as well as translation. Okay, so roller support allows rotation as well as translation. That means what? In case of now roller means what? It is a wheel. So these are the wheels. Small wheels have been provided here. So when I apply some force, say in horizontal direction onto the beam, it can roll, something like it can roll along this support. Okay, so as well as at the same time rotation is also possible. right, in case of roller support. So usually in case of what we can say the beams, say in case of bridges, especially in case of bridge, one support is the hinge support and the other one is the roller support. Why it is done? Because so suppose maybe due to what I can say, suppose the vehicles are traveling over this, say suppose bridge, and when say suppose when sudden brakes are applied, when say suppose sudden brakes are applied by the not allowing translation. Brakes have been applied and both the supports are not allowing translation, and because of that what happens, some additional stresses, the supports are subjected to additional stresses. Whereas I mean on the other hand, if one end is a roller one and when the other end is a this thing one, and when we apply a brakes, a horizontal force will be induced onto this beam, and because of which what will happen, as this beam, this end, say suppose this end B is free to roll, so additional will not be induced. Okay, and that's why usually in case of these things, simply supported beams, one and the other. Hey, who is there? Sia. Hello. Yesterday also she was. Hello, Sia. What are you doing? Sia, can you listen me? Sia, please call her someone.
तू काय बोलतोय, काय घ्यायला घेतला?
Okay, fine. Right. Now hereafter I won't allow her unless her parents call me. Okay, fine. Coming back. Simply supported beam. Okay. So this is in usually in case of simply supported beam, this thing one end is a hinged one and the other end is a roller one. On the other hand, say suppose now both the ends are, say suppose roller. This is also roller as well as this one is also roller. And when the brakes are applied onto this, I mean by the driver onto the vehicle, and when due to the application of brakes, a horizontal force may be developed, maybe either leftward or rightward, and because of which what happens now, as both these supports are roller, so beam may move in maybe forward or backward direction, something like this. Okay, which must be avoided, right? Fine. I hope you have understood this particular what I can say, the discussion, right? Then other end is a overhanging beam. Overhanging beam means what? Of course, again in case of overhanging beam, one end is a, I mean one, and the other one is a roller one, but some part of the beam is a overhanging one. Okay, so that is why it is called as overhanging beam. Next type of support is a cantilever beam. Cantilever beam means what? Just like a porch, you might have seen porch. Now in case of porch, one end is a fixed one. Okay, so this is the fixed one and the other end is free. Please note that. Okay, so this end is a free, the other end is a free one. Okay, so this is called as cantilever beam, just like a porch, right? Now these three types of beams, A, B, C, these are called as statically determinate beams. Okay, so what do you mean by statically determinate beams? So in case of statically determinate beams, number of unknowns are equal to or less than the number of equilibrium equations available. Okay, I hope you understood the definition of statically determinate beam. So number of unknowns, say u, is usually less than or equal to the number of equilibrium equations available. Okay, and hence we can solve for this number of, those number of unknowns by applying the conditions of equilibrium, that is summation fx0, summation fy0, and summation moment 0. As we know, the maximum number of equilibrium equations available are 3. Okay, right. Now the next type one is a statically determinate beam, which is a continuous beam. So this is a continuous beam. Continuous beam means what? Suppose this single beam is supported on more than 2 supports, or say suppose 2 columns. So this is column number 1, column number 2, column number 3, and there can be a number of columns, something like this, say column number 4, and so on. So this is called as continuous beam. And next one is beam fixed at one end and simply supported at the other end. So one end is a fixed one, okay, and other end is a roller one here. Okay. Next type of statically indeterminate beam is both the supports are fixed. Both the supports are fixed. Okay, so these are the statically indeterminate beams. Now, what is meant by statically indeterminate beam? In case of statically indeterminate beams, the number of unknowns are greater than the number of equilibrium equations available. Okay, so here that means u is greater than, number of unknowns are greater than the number of equations available. So for example, number of unknowns are 4, which is greater than the number of equations available 3. So here we cannot solve, we cannot solve such types of problems only by using the conditions of equilibrium. We need to develop some additional equations. Okay, so of course only this type of statically determinate beams are there in our syllabus, first year syllabus, while those who are from civil engineering, mechanical engineering, they will study the statically indeterminate beams in in the second year. Okay, structural analysis subject. Okay, so no need to worry about statically indeterminate beams. Okay, one more type of beam is that is this compound beam. Now compound beam means what? A beam which is made up of 2 or more beams. Now say for example, this is AH is one beam which is connected by means of hinge. So this is a hinge, internal hinge, this is called as hinge, connected by means of this beam AH is connected to the other beam, say HB, by means of this internal hinge at H. So this internal hinge means what? It is just like a ball and socket arrangement, just like a mirror of your two-wheeler vehicle. Okay, two-wheeler, right? So ball and socket arrangement, the arrangement is something like this. Okay, I hope all of you might be aware about this ball and socket arrangement. Okay, something like this. So this is the ball inside. Okay, and this is what we can support, right? Something like that. Yeah. Okay, so here what we can say now, this is the ball which is held in this particular, say, socket, right? And so suppose now this is a mirror, something like this, right? So this is a mirror. Now this mirror can be rotated in any direction. Okay, mirror which is fitted on your two-wheeler, maybe in case of four-wheeler also. Okay, so this arrangement is called as ball and socket arrangement, which is also known as internal hinge, which allows rotation but no translation. Right? I hope you got my point, right? Fine.
Yes, sir.
Okay, so this is fine. The same thing here, compound beam. Let us discuss the different types of loading on the beam. So first type of loading on the beam is a point load or the concentrated load. Okay, the point load or the concentrated load. So point load means what? This load is concentrated at a single point. So for example, this beam AB, which is acted upon by this force F1 and F2. Now the magnitude of this force F1 is concentrated at this particular point, say 1, onto the beam. Similarly, the F2, they say suppose F2 is a magnitude, say suppose 200 Newton. So this 200 Newton is concentrated only at this particular location, say 2. Okay, this is called as concentrated load. Second one is uniformly distributed load. In short, it is called as UDL. Okay, so in case of uniformly distributed load, every unit length of a beam is subjected to the same intensity of loading. Please note that every unit length. Okay, so every unit length of the beam is subjected to the same intensity of loading. Say for example, now say this is a beam AB, which is subjected to uniformly distributed load, which is subjected to UDL, which spans over the span, say L, I mean over the distances, suppose CD. Okay, this is D point, right? And this the magnitude of this uniformly distributed load is, say, suppose W Newton per meter. W, for example, say 2 Newton per meter means what? Every unit length per meter means 1 meter. Okay, so every unit length of the beam, say 1 meter length of the beam is subjected to the same intensity of loading, which is 2 Newton. Okay, so that is what is called as uniformly distributed load, right? So for finding the reaction, usually our question will be, as far as suppose this question is concerned, say simply supported beam which is subjected to some loading, something like this, maybe point load, UDL, etc. The question will be to find out the support reactions. Say this is a reaction, support A and say support B. So when this beam AB is subjected to some loading, something like this, say point load, concentrated load, or say uniformly distributed load, etc. Then our question is to determine the reaction at the support A RA and the reaction at the support B RB. This is our question. Now to find out the support reaction, what we have to do? We have to convert this UDL into a concentrated load. I mean this point load, concentrated load or the point load. And one more thing, so, sometimes this UDL, uniformly distributed load, may also be represented by as a like a rectangular load, something like this. Okay, like this, whose now this is rectangular load whose height, this height is same, which is say suppose 2 Newton per meter, for example, 2 Newton per meter. Okay, so these are the two symbols which are usually used in the your question paper. Please note that either something like this, U, ulta U, number of ulta U, or maybe this a rectangular one, something like this. Okay, so from that you must understand that this particular notation represents uniformly distributed load, right? So for example, this UDL of magnitude 2 Newton per meter is acting over a span of, say, suppose 4 meter. Okay, now it is required to convert this UDL into a point load. So how to convert this UDL into a point load? So now this is your beam. Okay, this is your beam, and these are the two reactions here. This is A and this is end B, right? So to convert this UDL into a point load, what you do? You multiply the intensity of the loading. How much the intensity of loading? It is 2 Newton per meter. So 2 Newton per meter multiplied by the span over which it is acting. Okay, the span is 4 meter. This 2 Newton per meter is acting over a span of, say, 4 meter. So what will be the concentrated load? Concentrated load is intensity of the loading multiplied by the span over which it is acting. That means 4 into 2. That means 8 Newton. Please note that now it is a concentrated load. What is the unit of this concentrated load or the point load? It is Newton. We know unit of this this 2 is Newton per meter, correct? Multiplied by unit of 4 is meter. So this meter gets cancelled. So you will get the concentrated load in Newton units. Okay. Now, what about the point of application? The point of application is at the midpoint of, I mean, in short, say suppose this is a rectangular loading. Rectangular loading means UDL, right? So to convert the point load, to convert the rectangular load into point load, in short, what I have done, in other words, I have taken the area of this rectangle, height 2 Newton per meter, and width, I mean length as a 4. Now, of course, through which point this concentrated load of magnitude 8 Newton will act? Through the center of gravity of this. Okay, through the center of gravity means what? Say from point C, from this point C, it is acting at a distance of 2 meters. Okay, similarly, from point D, it is acting meter. Okay, because the span is total span from C to this thing D is 4 meters. Right? I hope you have understood this point. Next type of loading is uniformly varying load, UVL. UVL. It is also called as triangular load. Okay, so here in case of this triangular load, the loading intensity is gradually increasing from 0 at say suppose C to say some intensity W Newton per meter at some other end, say at D. Right, so this is this intensity of loading is gradually increasing or linearly increasing, what we can say, linearly increasing. Again, here in order to, our aim is what? Our question is to find out the support reaction RA and this RB. So to know this support reaction or to calculate the support reaction, first of all, you convert this triangular loading into a point load. Okay, so how to convert this point load? How to convert this triangular loading into a point load? Similar to this rectangular loading, you take the area of this triangle. Okay, say suppose this L is say suppose 4 meter, for example, right? And intensity at this other end is say suppose 2 Newton per meter. Okay, and hence what will be the point load P? The point load P is equal to area of the triangle is 1/2 base is 4 meter, right, into the height is this height is 2 Newton per meter, 2 Newton per meter. Okay, so this meter gets cancelled, and hence you will get this concentrated load as this thing. Again, fine, this 2 gets cancelled, so concentrated load as 4 Newton, right? So this concentrated load is 4 Newton. Now, what about the point of application of this P, whose magnitude is this thing 4? Through which point? Can anybody answer? This concentrated
Center.
load.
Center.
Don't say center. Say centroid. Okay. So it will pass through this centroid, or say you can say center of gravity. No issue. Either you say center of gravity or say centroid. Okay. So this point load will pass through the centroid of this triangle, and we know the center of gravity or the center of a triangular figure lies at a height of how much? h/3 above base. Okay, so what should be, can anybody answer, what should be this distance? This one
h/3.
H is how much now?
L/3.
What is h?
L/3.
Yeah, L means, okay, here I have considered L as 4, means 4/3 meter. Okay, okay, right.
Yes,
then
sir.
Next, yeah, then last type of loading is the trapezoidal loading. So trapezoidal loading is something like this. See here what is happening in the loading intensity varies uniformly from lower intensity W1 Newton per meter at one end, say some point say C, to higher intensity W2 Newton per meter, something like this. So this is triangular loading over a span say L meter. So W1 is expressed in Newton per meter unit, or maybe sometimes kilonewton per meter, and also W2 is expressed in the same unit, either Newton per meter or kilonewton per meter unit. Okay, now what you do, you divide this trapezoid into two parts. So first one is this as a rectangle. Rectangle means what? Rectangle means what? Yes.
UDL.
Correct. Uniformly distributed. And the second one is this as a triangular loading. Okay. So I have divided this trapezoidal loading into two types of loading. It is a combination. I have written here. It is a combination of UDL of intensity W1 Newton per meter. This much. Correct. And uniformly varying load, that means triangular load of intensity varying from 0 here to this intensity. How much? This difference W2 minus W1. Okay. Again, of course, this the concentrated loads, these two concentrated loads will act through the center of gravity of the respective area. Right. Okay. Now already you know how to find the center of gravity of the triangle and center of gravity of this rectangle. Okay. So here I have shown. Yeah, here I have shown. Let me clear the screen. Yeah. So here, okay. So this is this is the point load because of this UDL. Because of this UDL, which is, so intensity of UDL is W1 Newton per meter multiplied by span will give us the load, I mean in Newton, concentrated load. And of course, it is acting at a distance of how much from point C? Of course, L by 2. Okay, right. Then next one is the triangular loading. Please note that we are considering these two loads separately, right? Now I am concentrating on only on this triangular loading. Okay, forget that there is no, say, this UDL loading, this lower rectangle. Only you concentrate on this triangular loading. Now convert this triangular loading into a point load. That means you find the area of this triangle. So how much the area of the triangle? 1/2 into base L multiplied by height. Height is W2 minus W1 and acting at a distance of how much? From point D, L by 3. Okay. Right. So let us discuss one numerical problem based on the beam. Okay. Right. Yes. So problem number 5. Determine the support reactions for the beam loaded and supported as shown in the figure below. Okay. So this is the beam A to B, which is supported. Now, of course, what is the type of support at A? Can anybody answer? Is it a fixed support or hinge support or roller support?
Hinge support.
Fixed support.
Correct.
Hinge
Hinge
support.
support. Correct. It is a hinge support. So this is a symbol for hinge support. Please note that. And what is the type of support at B? It's a
Roller support.
Roller.
correct roller support. Correct, roller support. Okay. And this beam AB is acted upon by a couple at point C. Please note that. Now this is a couple of magnitude 2 kilonewton meter, right? And then an inclined load of magnitude, of course, a point load or concentrated load of magnitude 10 kilonewton at an angle of 30 degree with respect to beam as shown in the figure. And then over the span, this A, B, C. Okay, this point is E. Okay. So over the point, I mean over the span DE, a UDL of magnitude 3 kilonewton per meter is acting and its span is 3 meter. Okay, and the total span of the beam is how much? Span means what? The total span of the beam. It is the distance between centers of the support. This is called as the total span. So total span of the beam is 3 plus 3 plus 3 plus 3. That means 12 meter. So span of the beam. This is called as the span. Okay, span of the beam. So what do you mean by span? Span is the distance between centers of the supports. This is called as the span. Okay. Right. So I hope you have understood this problem. Now, of course, the question is to determine support reactions. Question is to determine the support reactions. So to determine support reaction, first of all, we have to draw the free body diagram of this entire beam. And I have drawn it here, okay? FBD, right, FBD. As A is a hinge support, so there will be two reactions, okay? So I have assumed AY in upward direction and say AX in horizontally leftward direction. Now see, I will tell you here in this particular problem why I have considered AX in leftward direction. Now see here, there is one inclined load, concentrated load. Okay, so this inclined concentrated load, which we are going to resolve into two components, one vertical and this one as a horizontal. Okay, of course, the direction of horizontal component will be in rightward direction, correct? In rightward direction. Okay, is there any other force which is having horizontal component? Yes. No, there is no any other force which is having horizontal component. Only this 10 kilonewton force is having horizontal component, right? Whose magnitude, of course, 10 into cos of 30. Now to balance this rightward horizontal component, the reaction developed at A, horizontal reaction developed at A, it must be leftward. Are you getting what I'm saying? Got my point? Yes or no? Okay. Anyhow, okay, even though you are unable to understand it, no, it doesn't matter, no problem. You assume the direction for AY and AX, whatever you want. You may assume AY either vertically upward or downward, AX may be leftward or rightward. It is up to you. After solving, if you get plus sign, yeah, the assumed direction is correct. Okay, we have discussed these types of problems, okay, in this chapter, right? Fine. Fine. Okay, so I have said some, okay, I have assumed now AX leftward, AY vertically upward, and then these loadings as it is. This couple of magnitude 2 kilonewton meter at C. Then I have resolved this 10 kilonewton force into two components, one vertical and then horizontal as shown in the figure. Then I have converted this UDL, this particular UDL, into a point load or the concentrated load. So what will be the magnitude of that concentrated load? This 3 multiplied by 3, which is 9 kilonewton. Of course, it is acting through which point? Say from point E or from point D. Yeah, it is acting at a distance of 3 by 2. Okay, that means the midpoint of DE, correct? Okay, which is 1.5 meter from D or say okay, this D or E. Okay, and then here this is a roller support, and we know this plane of support is horizontal, so there will be only one reaction at the roller support, which is perpendicular to the plane of support. Okay, and here I have assumed RB in vertically upward direction. Now once you draw this FBD of this entire beam, then apply conditions of equilibrium. So drawing the free body diagram is a very important step in equilibrium. Okay, fine. So now the same figure is I have repeated here. Okay, then of course which equation we are going to apply? No doubt summation moment. And about which point we are going to take moment? About point A, because the maximum number of unknowns are passing through point A. So ultimately, how many unknowns are there? AX, AY, and RB. So 3 unknowns are there, 3 equations. So this is a statically determinate structure. Okay, fine. So applying summation MA is equal to 0, and of course we are choosing our usual sign convention, that means anti-clockwise as positive. And moment it is as the entire beam is in equilibrium, and it is A is a hinge support, and we know at hinge support the moment is 0 because it allows rotation. Okay, now let us take moment of each force about point A. Now first I'm going to take moment of this couple. So this is a couple which is applied in clockwise direction. Okay, so can anybody answer how to take moment of this couple? Please note that this is a couple or a moment of magnitude 2 kilonewton meter acting in clockwise direction. So while taking the moment of this couple, simply you add or subtract depending upon its whether it is clockwise or anti-clockwise. Okay, don't multiply by distance, please note that, because it is already a couple or it is already a moment. Okay, so as far as our sign convention is concerned, we are considering anti-clockwise as positive, while this applied couple is in clockwise direction, so -2, that's all. Okay, the next moment of this vertical component in which is in vertical downward direction, which is 10 sine 30, that is 5 kilonewton. They are sum with the perpendicular distance between this vertical component and point A. It is 3 plus this 3, which is 6 meter, and producing clockwise moment. This vertical component 5 kilonewton producing clockwise moment, so minus. Okay. Next moment of this, again another vertical force 9 kilonewton about point A. Yeah, how much the perpendicular distance? So this much is the perpendicular distance, correct? What is that? This 3 plus this additional 1.5, correct? 1.5. That means 6 plus 7 point, sorry, yeah, 6 plus 7.5, which is 7. 6 plus 1.5, which is 7.5. Okay. The next moment of this RB A. Now RB tend to rotate point A about in which direction? In anti-clockwise direction. So plus RB into perpendicular distance, which is nothing but what? This total span, which is 12 meter. So in this equation only unknown is RB. So and hence we got RB as plus. Please note that after solving we got plus sign to this RB. So plus sign means what? Assume direction of RB is correct. Plus sign means upward. It doesn't. Plus sign means it is acting in upward direction. No, this is wrong conclusion. Plus sign we have got after solving. We have got plus sign means what? Means what? Our assumed direction of RB is correct. And what is the assumed direction of RB? It is upward. So it is RB is acting in upward direction. Okay. Next, then you apply other two conditions. Let's apply summation of y is equal to 0. Of course, now I am considering, say, this as a sign convention. Upward force is positive. Okay. So starting from left hand A plus AY, correct? Plus AY. Then this minus 5 acting in vertically downward direction. So minus, then minus 9, right? And already we know RB, which is 8.29 in vertically upward direction. Please note that. So plus 8.29. So after solving, we got AY as 5.71 kilonewton. Again, after solving for AY, we got plus sign. You can check the calculations at home. Okay, after this class, right? So we got AY with plus sign. AY plus sign means what? Our assumed direction of AY is correct, which is vertically upward, and that I have shown this. This vertically upward. Then apply summation fx is equal to 0. So this is our sign convention. Rightward positive, right? So summation fx is equal to 0. So this is minus ax. Assumed direction of ax is we have assumed leftward. So minus ax. Then what next? Horizontal component of this this 10 kilonewton force, which is 10 into cos of 30, right? So this one, which is 8.66 kilonewton. So plus now this 8.66 is in horizontally rightward direction. That means in positive x direction. So plus 8.66. So after solving, we got ax as, again ax as with plus sign. Please note that. See here. After solving this equation, we got ax with positive sign. Positive sign means what? Assumed direction of ax is correct, which is leftward. Please note that. Now see here, we got plus sign for ax. So plus sign for ax, it doesn't mean that it is acting in positive x direction. No, this is wrong conclusion. We got plus sign for ax. It means that assumed direction of ax is correct, which is assumed direction is leftward. So leftward. Okay. I hope you got the answer, right? And then you find out the resultant reaction axis. Okay. So this is your AY, right? And this is AX. These are the corrected directions of AX and AY, and this is your resultant reaction at ARA. Okay, and then you find out this angle theta. Okay, now we have discussed how to find this angle theta, right? So this theta is tan inverse of, yes, tan inverse of AY by
AY
AX.
upon AX.
Correct, and you can find out the magnitude of this RA as root of AX square plus AY square, right? So this calculation you can do at home, right? I hope you have understood this particular problem, right? So already I have shared this material with you all. So please go through all the material, right? So now this is the right time to stop this lecture. So we will stop here.